We are continuing in chapter 5, proving triangle congruence. This time we are going to be looking at the two theorems, angle side angle and angle angle side. All right, so let's start with angle side angle. Angle side angle, what you will notice is two corresponding angles have to be congruent, two sets, and the side between them has to be congruent. So remember, this is what we call the included side, okay? In other words, it has to be between the two angles, okay? It has to be between the two angles. So in order to use angle side angle, you need three things. You need two corresponding sets of angles congruent, and you need one corresponding side congruent that falls between the two angles. Next, we have angle side, which is very similar, but this time the side is excluded, and that means it is not between the two sides. The two angles, sorry. Okay, so this time now the side is not between the two angles. All right, so let's take a look at this. So on this first one, what I always like to do is I like to go through and mark up my figure of what I know. So right now I know this angle and this angle are congruent. I know this side and this side are congruent. So the next question I ask is there another angle or side that we could get? And the answer is yes. I could get this angle and this angle because those two angles are vertical. So therefore they are congruent. So now when you look, the side is the included. It is between the two angles that we have. So this would be side, this would be angle side angle to prove it, because the side is included between the two angles. Okay, let's go to the next one. Here we have two angles. I have this angle and this angle congruent. I have this angle and this angle congruent. And I look at what else I can prove. Well, I can't get the third angle, but I can get this side congruent to itself. So if you look, I have two angles and a side, and that side is not included. It's not between the two angles, so therefore this one would be angle angle side. Okay, so now let's take that and put that into a proof. So here we go. We know that AD bisects angle BDC, and we know AD bisects angle BAC. And my goal here is I want to prove these two triangles congruent. So what does an angle bisector give us? Okay, so when you think about it, an angle bisector cuts an angle in half. So it looks at those two, and it says that those two angles would have to be congruent. Okay, so when we look at this, we know that AD bisects BDC. So what I can prove then is I could prove that this angle BDA and this angle CDA would have to end up being congruent. I also know that it bisects the other angle too. So I know that I should be able to get those two congruent. Then the last thing is I look and I see that I have a side congruent to itself. Now, remember, when we do the side lengths and the angles, always reference the names of the triangles that you're proving, because then what that gives us is that tells us that the order that we need to write those in, okay? So when we look at this then, so let's start proving. So the first thing I'm going to get is I'm going to start with the BDC part. So I'm going to go angle BDA is congruent, BDA, so look down here, BDA, so I start in the middle and I go out and then all the way back. So I'm going to start in the middle, go over, all the way back, is congruent to angle CDA, okay? And that is by the definition of angle bisector, okay? I also know that angle BAD, and again, BAD, so CAD, have to be congruent, and again, by definition of angle bisector. Now that I know that, then my last piece that I need is I need segment AD, and I look here at my naming. So when I look at my naming, I notice that AD and AD are in the same order. So that tells me that they would be listed the same. And that is because AD, and that is with the reflexive property. So since it looks identical on both sides, then that gives me that part. So now I've got two angles congruent and the side between them. So I have triangle ABD is congruent to triangle ACD by angle side angle. Okay, let's try another one here, something we know and what we need to prove. So we know by the given that angle A and angle L would have to be congruent. We also know B is the midpoint of CH. So because of that midpoint, we are going to definitely have to get CB and HB or BH to congruent. And then I look and I say, okay, is there something else I can get? And the answer is yes. I know those two angles are vertical angles, so they would have to be congruent as well. So now I'm ready to start writing. So I'm going to start with my sides. I'm going to go side CB is congruent to, and remember I'm looking at the order, so CB, so I'm going to stay in that same order, HB. And that is because of the midpoint theorem, that those would be congruent. Then I'm going to come back here and I'm now going to say my angles. So I'm going to go angle ABH is congruent to angle, now we go ABH, so LBC. And the reason that is because vertical angles are congruent. Okay, so that gives us that. So now I'm ready to write my triangle congruent. So AHB is congruent to triangle LCB. And that gives me, because AHB is congruent to LCB, I have two angles and a side not included. So that would be angle, angle, side. Okay, let's try this last one here. So what do I know and what do I need to get? So here we go. I know that 2 and 4 are congruent. And it also tells me that RL is parallel to DC. Okay, so I know RL is parallel to DC. Now, what does that help me with though? Remember back, if I have two parallel lines cut by a transversal, then what that tells me is that those two angles, the alternate interior angles, would also be congruent. So I'm going to be able to get 1 to 3 congruent. I also know then that DL is congruent to either DL or LD, depending on how they want it written. Okay, so it's congruent to itself. So we're going to start off, let's start with angle 1 is congruent to angle 3, and that is the alternate interior angle theorem. Then I also know that DL is congruent to, so I look here, I have DL, and that would be congruent to LD. and that is by the symmetric property. So now I have two angles and the side between those. So therefore, I know that triangle RDL is congruent to triangle CLD by angle, side, angle. And that is our second day of triangle congruence theorems. So we have side, 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 angle, side, angle, side, angle, and angle, angle, side. Okay, so just be careful.